So why does standard deviation matter? Because it gives me a measure of the variation in my data. Let's see how we calculate it. Got my situation. We're talking about the dry time for paint. What are the other ingredients do I need for calculating standard deviation? I need X bar. That's our symbol for the mean. Do you know how to calculate the mean? Well, everybody knows how to calculate the mean. I add up. This is the Greek letter sigma that just stands for adding up a bunch of values. I add up all my data values. I'm going to call all my data values X sub i's, where I is equal to my first through my last data value. And in statistics, we always call the last data value the nth value. So I have n values in our particular situation. N is equal to 10. So how do I calculate the mean? I add up all of my data values, and you know what I do next. I divide by the number of my data values. And that's where my 2.5 hours came from in this particular situation. I don't know if that ran off. So I need a mean to calculate a standard deviation. What else do I need? I need a deviation. And a deviation is the statistical term for, in math, you call it a difference. Which means what? I have to subtract two things. And for a standard deviation, the deviation I'm talking about is the difference between the mean of your data set and each data value in your data set. So for every piece of data in your data set, to calculate the standard deviation, you must calculate a deviation for each of your data pieces. How do you do that? You simply take the mean and you subtract the data value. The other ingredient I need, and I'll come back to deviation in a second, is a square. The other ingredient I need is we've already talked about this, a summation. I need to add up some numbers. So far, not too difficult, huh? And the last thing I need last ingredient I need for a standard deviation is, well, last two ingredients are an n minus 1, I'll talk about that, and finally I need a square root. That's what I need. Let's go back up to deviation and talk about an example of how we calculate that. So for our data set for paint B, our first three X sub i's, actually we'll just look at the first two and the last one. So my first data value is 15, my second data value is 0.1, and we'll go down and look at the 10th data value, which is 1.2. And if I was going to calculate my deviation for each of these data values, I'd take the mean and I'd subtract my data value. So the deviation for my first data point is the mean of 2.5 hours minus 15, which gives me, about negative 12.5. My second data value of 0.1, I use the mean to calculate the deviation minus 0.1 to give me 2.4. And my last data value, to calculate its deviation, I use the mean of 2.5 minus 1.2 to give me a deviation for that 10th data value of 1.3. Now, as I mentioned earlier, you have to calculate a deviation for every data value. I'm just illustrating it for those three of our data values. In fact, I've already calculated it on screen for all 10 data values, and you can see right there are my 10 deviations. In the case of that deviation, I subtracted the mean from the data value. It doesn't really matter what order you use, as you'll see why in a second. So I have a bunch of deviations, but we notice we've got negative deviations and positive deviations, And the people that invented this measure decided that we can't have deviations canceling out each other, positive ones and negative. So what did they do? They said we should square each deviation so that we have a measure of positive distance from the mean of our data points. And so when we square each of these deviations, we get a positive value for each of our deviations, except now we have what are called squared deviations. The next step in the next ingredients is we need to sum up or get a total squared deviations. So we take our squared deviations and we add them all up. Just let me put on this summation sign what we've done so far. We've said let's start with a mean. Let's subtract a data value from the mean for every data value. That's my x sub i's. Let's square the deviations. And then now we're going to add up all those squared deviations. When we do that for this specific example, we are come up with this value. You can see we add up. In this software it says sum instead of that Greek symbol sigma. We add up all the squared deviations. We come up with a value of 180.74 for our 10 data values from paint B. The next step is we divide by n minus 1 because we don't want to know the total square deviations, we want to know the average. And when we calculate a standard deviation, instead of using the total number of data values for our average, we use the total number minus 1. So that's why we use, in this case, a value of 10 minus 1 or 9. And when we divide our total sum of our squared deviations by 9, we get a value of 20.0822 in this example. Divide it by 9 and we end up with 4.48, which is the standard deviation that's calculated by the software. I did one more thing to get that 4.48. Divided by n minus 1, and I took the square root of that average squared deviation, and that's the square root step of calculating the standard deviation. And you end up with your standard deviation.